The arithmetic sequence a plus d, a plus 2d, a plus 3d, a plus n minus 1d has the following properties. When the first, third, and fifth, and so on terms are added, up to and including the last term, the sum is 320. When the first, fourth, seventh, and so on terms are added, up to and including the last term, the sum is 224. What is the sum of the whole sequence? So we have a plus d, a plus 2d, and so on, a plus 3d, all the way up until we get to the final term, which is a plus n minus 1d. And this has n terms. We don't know the value of n, so we have to make some decisions later on as to what n could be in terms of being even, being odd, divisible by 2, divisible by 3, and so on. Now, we are going to first, let's look at the first criteria, that the sum of the first, third, fifth, and so on, including the last term, have to add up to 320. All right? That basically means that a is the first term, the third term, which is a plus 2d, the fifth term, a plus 4d, and then I guess they're hopping over 2. So a plus 6d, a plus 8d, and so on. All the way up to and including the last term, which is a plus n minus 1d. And there you're saying that is equal to 320, that sum. All right. We have to make a decision here as to what is n. We don't know the value for n. We don't know what it is, how many terms there are in this arithmetic sequence. They have not told us that. But in order to get some sort of a relationship, we've got to make a decision as to what it is. Is it going to be odd, even, divisible by 2, divisible by 3, and so on? So I'm going to say that n minus 1 is even. Okay? Now, if I'm wrong, I can always change my decision later, but I've got to start somewhere. So if n minus 1 is even, that means n is odd. Okay? So now let's sum this all up. This is going to be, how many a's do we have? Well, we've got n minus 1 right here. We've got to divide that by 2, and we've got to add 1 to it. And that's how many a's you have. And then these 2d's, 4d's, 6d's, something can factor out from all of those. We can factor out a 2d. And if you do, you get 1 plus 2 plus 3 plus 4 plus ... all the way until n minus 1 over 2. And this is all equal to 320. Okay? So let's keep going here. This becomes n plus 1 over 2, if you do the math there, a plus 2d. This whole thing, as I'm sure you know, if you add up consecutive numbers, 1 plus 2 plus 3, all the way up until n, that is equal to n times n plus 1 over 2. So using that formula, this becomes n minus 1 over 2 times n minus 1 over 2 plus 1 all over 2 is equal to 320. All right, so let's just keep going here. We got to simplify this expression now. This one stays the same, n plus 1 over 2 times a. And this one becomes n minus 1 over 2 times n plus 1 over 2. And then I'll just bring the half out front like that. And at this point, I think I can just factor out an n plus 1 over 2. And if I do that, I'll have a plus 2d times n minus 1 all over 4 and that is equal to 320. And I will call this equation 1. All right, that's about as far as I can go there. Now we need to look at the second criteria right here. The first, fourth, seventh, and so on terms are added up to and including the last term. That sum is 224. All right, so the first and then the fourth term and then the seventh term and so on, the 10th term, are all added up to and including the last term, which is a plus n minus 1d, like that. And that is all equal to 224. Okay, now again we have to start making a decision here as to what n can be, because we don't know. So to make this work in a way that I can add it all up, I will let n minus 1 be even, just as I did previously, because I have to be consistent. But this time it's not as simple. I also have to let n minus 1 be divisible by 3. And that's the only way I'll be able to add these in a way that will give me one solid equation at the end. All right, so for example, if you're kind of wondering this to be a little bit more abstract than you had hoped, a value that would work is n minus 1 equal to 12. N minus 1 equals 12 makes that even and divisible by 3. Okay, so let's go with that. This is just an example, by the way. All right, so here we go. Let's add all this up. So again, we get how many a's? N minus 1 divided by 3 plus 1, a. And then from all of those, you can factor out a 3d, and you'd get 1 plus 2 plus 3 plus ... all the way until you get to n minus 1 over 3. And that is all equal to 224. So simplifying, this becomes n plus 2 over 3, a, plus 3d, and if you use that fancy formula, you get n minus 1 over 3 times n minus 1 over 3 plus 1 all over 2. This becomes n plus 2 over 3 times a plus 3d n minus 1 over 3 times n plus 2 over 3, and we've got this a half. And I think I can factor out at n plus 2 over 3, and that would give me a plus 3d times n minus 1 over 6 is equal to 224. And I'll call that equation 2. Now, since we have looked at the two criteria, let's look at the entire whole sequence. A plus d plus a plus 2d, and so on, all the way up until the very last term, which is a plus n minus 1d. And let's add all of that up. So this is going to be n times a plus, factor out a d, and you get 1 plus 2 plus 3 plus ... all the way up until n minus 1, like that. And then this will be n times a plus d times n minus 1 times n minus 1 plus 1 all over 2. And this looks like n times a plus d times n minus 1 times n all over 2. And factoring out an n, you get a plus d times n minus 1 over 2. And there you have it. This is the sum of all the terms, the entire sequence, the whole sequence. So let's summarize our findings. Equation 1, equation 2, and the total sum. So these are my findings that I have figured out thus far, and the hope is that it will help me figure out a numerical value for the total sum. All right, now let's remind what my criteria was. I stated that n minus 1 had to be even, and that n minus 1 had to be divisible by 3. All right, let's start plugging in numbers. What kind of numbers do you want to use for n here? Let's take a look. Let's look at this and see if anything comes to mind here. We got 3D, 6D, 9D. Just brainstorming. I think I'm going to first start with n equal to 13. Why? Because if I do that, n minus 1 will be 12, and that meets both of my criteria. It's even and it's divisible by 3. Let's see what we get for equation 1 and for equation 2. For equation 1, that will give me 13 plus 1 over 2, a plus 2d, 13 minus 1 over 4 is equal to 320. And that gives me 7 times a plus 2d times 3. And that gives me 7a plus 42d is equal to 320. And if I divide by 7, I'll get a plus 6d is equal to approximately 45.7. All right. How about equation 2? What will I get using n equals 13? Okay, we got 13 plus 2 this time divided by 3. A plus 3d. And I've got 13 minus 1 over 6 is equal to 224. All right, that looks like a 5a plus 3d times 2 is equal to 224. And that looks like 5a plus 30d, if you multiply this all out, is 224. If I factor out a 5 or divide through by 5, I get a plus 6d is equal to 44.8. Oh boy, that doesn't work. A plus 6d is 45 there. A plus 6d is 44. Okay, that means that this is not right. No problem. Let's keep going. Let's get another number for n that's even and divisible by 3. Let's just go up to the next one, which I believe would be 19. That would make n minus 1 18, and 18 is indeed even and is also divisible by 3. All right, let's do this again. So equation 1 here, this time becomes 10, correct? I'm just substituting 19 for n. 10 times a plus 2d, 18 over 4 is equal to 320. And that looks like 10a plus 90d is equal to 320. And divide through by a 10, we'll get a plus 9d is equal to 32. Okay, let's plug in n equals 19 into that second formula. That looks like it will give me 7 a plus 3d times 3 is equal to 224. This looks like 7a plus 63d is equal to 224. Divide through by 7, you get a plus 9d is equal to 32. All right, perfect. We got it. Both of those match. So n is indeed 19. Great. Now I can use that to figure out my total sum. So let's move this up a bit. Total sum is n is 19, and then we've got a plus d, 19 minus 1 over 2, like that. And this is 19 times a, that looks like 18 over 2, which is 9, so 9d. Well, a plus 9d, we just figured out, was 32. So that's 19 times 32. And if you do that multiplication, you get 608. So there you go. That's the answer. The answer, therefore, to number 24 is 608, which is choice C.